In this problem, we are given several rational functions, and we are to find the horizontal intercept and the vertical intercept for each. Let me draw a coordinate axis to remind you that what we usually call the x-axis can oftentimes be called the horizontal axis because the line is horizontal. We do this because a lot of times our input variable isn't x. So to have a more generic name for the x-axis, we call it the horizontal axis. If I was to draw what is usually called the y-axis, I could argue since it is a vertical line, just in case my output variable isn't y, for example in this case it's f of x or g of x, this y-axis can be called the vertical axis regardless of the output variable chosen. So this is my vertical axis. Now here are the rules to find the horizontal intercepts and the vertical intercepts, but to help you remember the rules, I usually tell my students that if you want to find the horizontal intercept, if you want to remember which the value, the x value, the y value that you want to set to 0, imagine just plotting a single point on the horizontal axis. Suppose this was 3, and I suppose I asked you to label that point in its full coordinates. You would say the x value is 3, and the output is 0. So if you just were to label one point on the horizontal axis, you'd see that the technique of finding the horizontal intercept is to simply set the output to 0 and solve for the input variable. That's just the reverse on the vertical axis. If you were to label a point, let's just say that this is 8 here. If I asked you to label the full coordinates of that point, you would say the x value is 0 and the y value is 8. So with the vertical axis, oftentimes called the y-axis, you have to set the input equal to 0, and it's right here. And plugging in 0, you simply evaluate the function to find its output. So that being said, let me erase this to give myself some room. Let me try a couple of these problems. I'm going to start with g of x. So with g of x, starting with the horizontal intercept, I'm going to take g of x and set its output equal to 0. That's this right here. So if I was to write this down, negative 3x plus 1 over 6x plus 12, to find the horizontal intercept, I'm going to set the output equal to 0. That's this right here. Now, because I don't like working with fractions, I'm going to multiply both sides by 6x plus 2 so that this will simplify out. In fact, it simplifies down to be the number 1. So this whole quantity in the denominator will cancel, if you will, with this quantity up here. I like to say it simplifies down to be the number 1. Anything divided by itself is 1, and in math it's legal to divide by 1, or excuse me, multiply by 1. At any rate, if you multiply the right-hand side by 6x plus 2, in math you have to multiply the left-hand side by 6x plus 2. But the nice thing about this problem is 0 times anything is 0. So it did not matter what my numerator was, excuse me, my denominator. It does not matter what the denominator is, because when you multiply it over, because 0 times anything is 0, you always get 0 here, leaving you with an equation that basically states that the output will be 0 as long as your numerator is 0. So as a shortcut method for my students, once they understand this, is I just have them write down the numerator, negative 3x plus 1, right equals 0, and then solve that for x, and that always works with rational functions. So to finish the problem, what I'm going to do is I'm going to subtract 1 on both sides. That would give me negative 1 over here. This would be negative 3x. And I'm almost running out of room, so I got to be careful. To solve for x, because the negative 3 is being multiplied, I'm going to divide it on both sides. And then over here again, you probably hear this cancels. Technically, better way to say it is that negative 3 over negative 3 is the number 1, and you no longer have to write the 1 because it's being multiplied, and multiplication by 1 in math does not need to be written. So these cancel if you want, or it simplifies down to be the number 1. Over here, a negative divided by negative is a positive, so I get that x is 1/3. Now be careful, up here it said round to the nearest hundredth as needed. So when I actually type this in as a point, because a horizontal intercept is a point on the graph, I found the x value 1/3 to be the x value for which the output is 0. So in math, I guess you're going to type this in point form. And this is to be evaluated at 2 decimal places. So 1/3 is 0.3 repeating. I'm going to round that to the hundredths place. And actually, I just realized that this is the answer to this problem down here. So I wrote it in the wrong spot. So this would be 0.33, comma 0. Now for the vertical intercept. The vertical intercept as I said before, is actually a little simpler. You replace x with 0. So if I was to take the original function g of x and just simply plug in 0, just everywhere I see an x value, I'm going to replace it with 0. This is a little bit easier because you don't have to solve an equation. You're simply evaluating this function at 0. So let me see, I replaced this x value with 0. Now I replace the denominator, all variables in the denominator with 0. Let's see. And then just keep simplifying out. 0 times anything is 0, and then you add 1. In the denominator, 6 times 0 is 0, and you add 12. So I get 1/12, and I believe that's 0.08, but let's just check to make sure. I have a calculator emulator here. I'm going to evaluate 1 divided by 12, and see if that's 0.083 repeating. So to 2 decimal places, to the hundredths place, I'm going to round to 0.08. So remember, with the vertical intercept, the x-coordinate is 0. We just found that the y-coordinate would be 0.08. Now let me move up and do this same process all over again for f of x, because f of x is a special case. At least one of the parts is a special case, and it's not going to look pretty if I leave all this stuff. So let me just rewind and start over, except for this time I'm going to work on f of x, because you may be watching this video because you didn't understand that one. So for f of x, starting with the horizontal intercept, again, you replace the output with 0, so that's this right here. So if I replace the output notation, f of x with 0, I'd have this. And I'll go through the explanation again, but as I said earlier in the video, you really could just write down the numerator and set it equal to 0. And the reason why is it does not matter what this denominator is. If you multiply the right-hand side by that denominator, and then, of course, doing it to the left-hand side as well, because you're multiplying by 0 over here, 0 times any denominator would be 0. So it does not matter what the denominator is. You always end up with the numerator set equal to 0, and you are to solve that equation. So the shortcut to this, if you realized it, would be to find the horizontal intercept. You simply take the numerator and write it down, set it equal to 0, and solve. Now, to solve this, we are to find x values for which 0 would be equal to -9. Well, that's absurd. 0 is never equal to -9, so there's no solution. So in Math AS, if there's no solution, we say it does not exist. The solution does not exist. So for horizontal intercept, capital D and E is going to work. For the vertical intercept, remember that's where you set x equal to 0. So that would look like this, replacing the input with 0. I have -9 in the numerator, and in the denominator I'm going to replace x with 0. So that's 2 subtract 2 times 0, and then go through this carefully. I'd still have the -9 in the numerator. And in the denominator, I have 2 times 0 is 0. So you'd have 2 to take away 0, which is 2, and you get -9 halves. -9 halves is the same thing as -4.5. All right, 2 goes into 9 4 times with 1 left over, and you'd have that as 1/2. So here, remember, we found the vertical intercept by replacing x with 0, and by doing so, we found that the y-coordinate would be -4.5. If you're patient, I will just do the last one, and I will skip the explanation, but just do the steps. So on the last one, if you've been watching the video, you realize to find the horizontal intercept for the bottom function here, you can skip to just setting the numerator equal to 0. That's -5x minus 9. And as long as that's 0, you will get a horizontal intercept. You can even see it. If this whole thing becomes 0, because 0 divided by anything is 0, this whole thing would be 0 as long as the numerator is 0, and that's exactly what we want. We want the output to come out to be 0. So at any rate, if you just let me add the 9 over, and then since the -5 is being multiplied, I could divide it over, and you would get -9/5. Type that in your calculator, or realize that -9/5 is the same thing as -18/10, if you let me double the top and bottom here. And then -18/10, of course, would be -1.8. So for that one, the x value that makes the output 0 is -1.8. And in some textbooks and some teachers, rather than calling this a horizontal intercept, they'll call that a 0 of the function, because it's literally the x value that makes the function 0. The vertical intercept, if you're being patient, would simply be replace x with 0. That's very easy to do. You'd have negative 5 times 0, subtract 9. And then in my denominator, since it's 4 times x, you'd have 4 times 0. And I guess this is a special case because in our denominator, 4 times 0 is 0. I don't even care what my numerator is. It makes no sense in mathematics anyway to divide by 0. There's no meaningful way to define that. So anything divided by 0 we typically say does not exist. If you're an engineer, you'll learn that sometimes we call it infinity or negative infinity, but that's for a different video. So hopefully this helped, and I will see you in the next video.